Hello student, I am Sonali Kelkar from City International School and today we are going to start with a new chapter, acids, bases and salts, right? In this chapter we are going to cover the topics acids, bases and salt, their definitions in terms of furnishing of hydrogen and hydroxide ion. Then general properties of acids and bases and salts, then examples and uses, then concept of pH scale, that is power of hydrogen scale, importance of power of hydrogen in everyday life, then preparation and uses of sodium hydroxide, bleaching powder, baking soda, washing soda and plaster of Paris. Okay, before we start with our new chapter, let's have a recap of what we did in our last chapter. Students, I have taken few questions which are important from the point of view of exam. So please note down these questions and answers are written. I'll just discuss the answer. You can write answer by your own if you want without looking at the answer which I have given. Okay, and then later on you can check your answers, right? So let's see the first question. A solution of a substance X is used for whitewashing. Name the substance X and write its formula. We know that we have discussed this in my last sessions of the first chapter, right? The substance which is important for whitewashers, calcium oxide. Okay, and write its formula. So calcium oxide is CaO. Then write the reaction of the substance calcium oxide, name in one above with water. So when calcium oxide solid react with water, it's give you calcium hydroxide. Okay, so calcium hydroxide nothing but slaked lime, and calcium oxide is called quick lime, right? Question number 2. An iron nail is dipped in the solution of copper sulfate for about 30 minutes. State the change in color observed. Give reason for the change. This has been asked in CBSE 2015, right? So, in this question, I would prefer you to draw a diagram and then color it, because copper sulfate, it is blue in color, so you will draw a beaker with blue color copper sulfate solution. You will show a iron nail dipped in the solution, right? And after some time what happened, so you can show another beaker where you can show faint green color, right? Because we know that the copper will be replaced by iron, because copper is more reactive than iron. Okay, so copper sulfate solution will change into iron sulfate solution. You have to write the reaction after you have drawn the picture, right? Here question number 3. Which of the statement about the reaction shows below are incorrect? Okay, now let's see the reaction. Lead oxide plus carbon gives lead plus carbon dioxide, right? As you can see, lead oxide PbO, right? And it was a reactant, and in product we are getting Pb. That means lead oxide has lost oxygen, so lead oxide is reduced, right? Then carbon was single, and then here you can see carbon dioxide. That means carbon dioxide has gained oxygen, so gain of oxygen, oxidation, right? And loss of oxygen is reduction. So lead oxide is reduced and carbon is oxidized, right? So let's see the option. Lead is getting reduced is absolutely wrong. First of all, the lead is given here in a product side, so no change happens in product side. The reactants, the change happens in reactants, right? Carbon dioxide is getting oxidized. No, carbon dioxide is not getting oxidized. It's carbon that is getting oxidized, right? So carbon is getting oxidized, correct. Lead oxide is getting reduced, perfect. So A and B are incorrect statement. This I have taken from your book. Question number 4. Ferric oxide, right? Fe2O3 plus Al, aluminium, gives Al2O3 plus Fe. Okay, in the above reaction is an example of, is it a combination reaction? No, it is not a combination reaction, because in a combination reaction two reactants react to form one product, whereas there are two products, right? Double displacement reaction, no, this is not a double displacement reaction, because only iron is replaced by aluminum. Okay, and there should be two compounds. We are having one compound and the aluminum is an element, so no. Decomposition reaction, no, it is not a decomposition reaction, because in decomposition reaction, okay, one reactant, okay, will decompose to form two or more products, right? So here we have two reactants. Displacement reaction, sorry. So yes, it is a displacement reaction. We know that iron is less active than aluminium, so iron is replaced by aluminium and we are getting aluminum oxide, right? Okay, question number 5. Here you have to write the balanced chemical equation of the following reaction, right? Calcium hydroxide. Children, here I want to tell you one thing. This type of reaction, the possibility of getting this type of reaction in exams is more, right? So first of all, when you make such kind of equations, right? When you write a skeletal equation, first of all, you should know how to write a product, or sorry, how to make a compound, right? So without knowing the compound formation, you cannot write a skeletal equation. So you need to practice how to form a compound, right? So calcium hydroxide, I'll give you just an example over here. Calcium, the valency of calcium is 2 plus and valency of hydroxide is negative, right? So there is always a exchange of valency. That is why OH negative or 1 negative, right? When we exchange the valency, we should avoid sign, right? So 1 will go to Ca. We don't write 1, by default it is 1. And what is the valency of calcium? It is 2 plus. That 2 will go to OH, right? So OH will get 2 and calcium will get 1. So we are getting calcium hydroxide. Now calcium hydroxide plus carbon dioxide CO2 gives calcium carbonate CaCO3. Usually when calcium react with carbon dioxide, you get calcium carbonate. This is fixed in these type of reaction, right? Calcium carbonate CaCO3 plus H2O, right? This equation is already balanced, right? If you see calcium, 1 element of calcium here, here also 1, right? Then coming to oxygen, right? Here oxygen is 2 and 2 4. Here it is 3 plus 1 4. Hydrogen 2, here hydrogen is 2, right? So hence the equation is balanced. Now coming to zinc Zn plus silver nitrate AgNO3, right? So Ag, the valency of Ag, that's a silver, is plus and NO3 is negative. So that get cancelled. 1 valency, 1 is positive, 1 is negative, so that get cancelled. So you just have to write AgNO3. Okay, so the compound form over here is AgNO3. Zinc nitrate, Zn has 2 valency, that is why NO3 is getting 2 here, and nitrate has 1 valency, 1 negative, so you just have to avoid sign. Okay, so 1 is over here, Zn1. Fine, you don't have to write 1. So zinc nitrate plus Ag. Now let's see the balancing of equation. Zinc is 1, no problem. Ag here 1, Ag is also 1 initially, right? Now nitrogen 1, here nitrogen is 2. So when you balance 2, so you need to write 2 over here, right? So nitrogen gets 2 on either side. Now let's have a look at oxygen. 2 into 3 6, here also 3 into 2 6. Okay, so we have to, this equation got balanced. Ag will get 2 here because you are writing 2 here, so silver is getting changed, so you have to write 2 over here. Practice the balance of equation by yourself. Now aluminium plus copper chloride, Al, aluminium, copper chloride, CuCl2, right? Copper chloride, here we have taken valency of copper as 2, right? So Cl2. Cl has 1 valency, so you don't have to write 1. Copper has 2 plus valency. The 2 will be written with chlorine, right? CuCl2 plus AlCl3 plus copper, right? Aluminum has 3 valency. That is why Cl3 is written here. And then you need to balance this equation, right? Aluminum was 1 on either side, right? Then coming to copper, 1 on either side. The only problem was with chlorine. Chlorine was 2 here initially and 3 here, right? Try to, when you are balancing the equation, try to uh, change this 2 into an even number, not the odd one. Okay, so 2 multiplied by 3, so you will get 6, right? Here 2 into 3, 6. Okay, so common factor between 2 and 3, it was 2 here and 3 here. What is a LCM, that is a least common multiple? 6. So try to make 6. So when 2 will multiply by 3, you will get 6. Here 2 will 3, you will get 6. Now in this case, because you have written 3 here, the copper has become 3. So you need to make changes here with copper 3. Okay. The next equation, barium chloride BaCl2 potassium sulfate K2SO4 gives BaSO4 and KCl. Okay, barium sulfate and potassium chloride, right? Here you can see barium was initially balanced, right? Chlorine 2, the chlorine was 1 here, so you put 2 over here, right? And then potassium 2, yes, it here also 2. Barium is 2. Barium, okay, barium is 1, it's balanced. Sulfur is 1, oxygen is 4. Now the whole complete equation is balanced. The most important thing over here, when you are given word equation, the most important thing is formation of compound. So this formation of compound, you should be perfect in the formation of compound. Only then you can form an equation, and afterwards you can balance the equation. Right, children? Okay, now coming to the chapter, our new chapter, acids, bases and salt. We are going to start with the indicators, right? You must have heard this word indicators because you did a litmus and acids base, I think in 7th grade, right? So indicators are the substances, okay, which when put in acid solution or basic solution, there will be a change in the color. Clear? So with the help of indicator, you can find out that the given solution, whether the given solution is acid or basic or neutral. Okay, so you can distinguish between the solutions with the help of indicators. Now there are two types of indicator basically. Indicators which we get from our nature, natural substances, right? These are indicator, natural indicator. And we also call these indicator as acid base indicators, right? If you get the word, what do you mean by acid base indicators, don't get confused. It is one and the same thing, right? Okay, because you identify whether the substance, the solution which is given to you is acidic or basic in nature. So we use the word acid base indicator instead of indicator, right? Both are same. Now coming to the natural indicators, you must have heard about litmus paper, right? So litmus paper, we get litmus paper from a lichen, right? We obtain from lichens. Now what are lichens? If you have heard about symbiotic association, then algae and fungi together, okay, they live in a symbiotic association, and from that lichens we get litmus paper, right? Turmeric, it's haldi, okay. You must have observed that if there is a stain in your cloth and you want to wash that stain, definitely when you wash it with soap, a soap has alkali in it, okay. So soap is alkali in nature, so when you rub that, you will find that it has changed into red and brownish color, right? So turmeric is also a natural indicator. Red cabbage, natural indicator. China rose, natural indicator, right? Other than this, in your book, they have given hydrogen, petunia and geranium. Okay, I haven't mentioned here, but it is given in your book. These are all natural indicator. Okay, now coming to the litmus paper. Suppose you have given 3 test tubes, and in that 3 test tube the solution are given. You don't know which solution is what, whether it is acid, base or water, right? And you have given 2 litmus paper, let's say blue and red litmus paper. When you dip let's say blue litmus paper in one of the test tube, and if it turns into red, blue litmus paper, if turns into red, right, then this that solution is acidic in nature, right? So in acids, blue litmus paper turns red, and if you dip red litmus paper, nothing will happen to it, right? Okay, now in case of the other test tube, let's say you have put a blue litmus paper. Sorry, let's say you have put a red litmus paper, and if red litmus paper turns blue, that means that is a base. Okay, so you can just identify the color with acid. Acid, red, base, blue, right? B for base, B for blue. So it is easy to understand. That means when you put red litmus paper, it turns into blue. So B for base, B for blue. So this is how you can, you know, you can have these key points, okay, just to remember if in case you get confused, right? Coming to the indicator, turmeric is another natural indicator. I have told you about this. Turmeric is yellow in color, right? So turmeric or turns reddish brown with base. I have discussed this with you. Turmeric doesn't change color with acid. Okay. Red cabbage, juice red cabbage is originally purple in color. Juice of red cabbage turned reddish with acid, turns greenish with base. Olfactory indicators, these indicators with the smell of these substances. Let's take onion, vanilla, right? For this, these are the example of olfactory indicator. And when you put into base and acids, there will be a change, or there might not be a change in their smell. See, olfactory indicator, we usually use this indicators with children who cannot see. Okay, so those who have any physical problem, right? So for them we use olfactory indicators, right, because they cannot see the change in color. Okay, so let's have a look of the table. Yeah, it's a synthetic indicator. Now synthetic indicators are indicators which we make in laboratories. Okay, phenolphthalein is a synthetic indicator, methyl orange is a synthetic indicator, right? And then phenolphthalein is a colorless liquid. It is a colorless liquid, and if you put acid in the colorless liquid phenolphthalein, there won't be any change. But as soon as you put NaOH, which is nothing but base, you can see it is turning, the solution is turning pink. Okay, methyl orange is originally orange in color. It turns red with acid, and it turns yellow with base. Okay, here's the table. Okay, here the red litmus paper, original color is red, but when you put into acid, there won't be any change because it was already red. But as soon as you put into a base, it will change into blue. Blue litmus paper, original is blue in color, but if you put in acid, it will change in red, whereas there won't be any change when you put in a base. Okay, basic solution or alkaline solution. Turmeric, it is yellow in color, with acid no change. Okay, you can do this experiment at home, right? You can take a solution of turmeric and try put some few drop of vinegar or citric acid or lemon juice, right? All are acid, right? So try to do this at home. And with base, though, I have already told you, you must have experienced this, right? With stain, and if there is a stain, okay, of any gravy, right, we usually put haldi or turmeric in gravy, right? So if you want to wash it with base, if you try to wash it with base or soap, right, stick, it will turn into reddish brown. Okay, Red cabbage juice, it is purple in original color, right? Acid, it turns reddish. In base, it turns greenish yellow. Okay. Then phenolphthalein, it's colorless. Acid, it will remain colorless, and as soon as you put base, it will change into pink, right? Methyl orange, this is originally orange in color. With acid, it will change in red, okay, and base it will change into yellow. Students, you need to remember this because they are very important. Questions of like 1 marker question can be asked on these, right? Can be 2 marker questions, but yes, 1 marker questions can be asked based on the indicators, right? Onion, um, we don't have to, because these are the olfactory indicators, so we don't have to mention about the color. Okay, it doesn't have any color, no need, it's not required here. With acid, if you take a onion juice, okay, and then put acid, there won't be any change. Okay, there won't be any change in smell, you can still smell like onion, right? And if you put base in it, the smells vanish. Okay, this is also you can try at home. And vanilla, you must be having vanilla essence at home, right? Try to put acid in that vanilla. Okay, there won't be any change, you can smell the same. Okay, but as soon as you put base into it, smells vanish, right? So this is all about the indicators. Now let's do an activity. This activity is given in your book, acid base, and in laboratory. This activity should be performed in laboratories, right? And we have so many of acids and bases, and then we have to test all these acids and bases with the help of litmus paper, red litmus paper, blue litmus paper, phenolphthalein solution, and methyl orange solution, right? Because red, blue litmus paper, phenolphthalein, and methyl orange, these all are available in school laboratories. That is why this activity is given, right? And even these chemicals, HCl is acid, okay, it is a strong acid, okay. HCl is a strong acid. H2SO4, sulfuric acid, very strong acid. HNO3, okay, nitric acid, strong acid. Then CH3COH is acetic acid, and the common name is vinegar, okay. Then sodium hydroxide, right? Then potassium hydroxide, all are bases. Magnesium hydroxide, ammonium hydroxide, and calcium hydroxide. See, sodium hydroxide and potassium hydroxide, these are strong bases, okay, and HCl and H2SO4 strong acids, right? So I'll explain you, when I will explain about the acid, I'll explain you what do you mean by strong acids and weak acids, right? Okay, now in strong acid, if I put red litmus paper, I won't find any change. In fact, in these acids, okay, in these acids, if I put red litmus paper, I won't find any change. But when I put blue litmus paper, it will turn red. Okay, here it will turn red. In case of acid, it will turn red. Okay, phenolphthalein, we have already seen there is no change, okay, in case of acid. But what about if I put all these acids in methyl orange solution? Okay, it turns pinkish red color. Okay, it turns pinkish red color. All acid will change methyl orange into pinkish red color. Clear? Now coming to the bases. Okay, 1, 2, 3, 4, 5 bases. All these 5 bases. Red litmus paper will turn into blue, right? With blue litmus paper, you won't see any change. Then phenolphthalein, yes, it will turn into pink. And in methyl orange will turn into yellow, right? Red or pink they have given in phenolphthalein, okay, or dark pink, fine. And methyl orange remains yellow, right? So these all are the changes that you will find with different solutions when you put acids and bases. Right, now coming to acids, You must have heard this word acids many a time. Okay. So what are acids? What are the properties of acids, right? Let's discuss all the properties of acids now. Acids are usually sour in taste. You must have heard about citric acid. Okay, all citrus fruit, orange, lemon, right? These all citrus fruits, they are sour in taste. Okay, so they are sour in taste. And what about the litmus paper? Just now we have done the indicator. If you put blue litmus paper, it will turn into red. Then dissolves in water to release hydrogen ion. See, the acidic property, that means the sour in taste is sour in taste. This is corrosive in nature, right? The acidic property is only because of hydrogen ions in acids, right? Every acid will have hydrogen in it, whether it is H2SO4, HCl, HNO3, H2CO3, carbonic acid, phosphoric acid, nitric acid, acetic acid, okay, formic acid, methanoic acid over here. All these acids have hydrogen in it because due to the hydrogen ion, the property of acid is persist. Okay. Now coming to the properties of acids. Acids have sour in taste. We did. Turns blue litmus paper to red. Yes, we did. Acid solution conducts electricity. It means, suppose you put, you can let me see. Okay, you can take a beaker, right? Put water in the beaker, water as a solvent, okay, H2O, right? Then put some HCl or any acid. Let's take HCl because HCl is a strong acid. As I told you, strong acid. Strong acid means every molecule of HCl will dissociate and you will get hydrogen plus ion, right? Hydrogen plus ion. So you will get many hydrogen plus ion. That means every hydrogen plus every molecule every molecule of HCl will dissociate. They will segregate. Okay, they will divide hydrogen plus and hydrogen plus and Cl negative, chloride ion and hydrogen ion, right? And if you put, okay, two carbon rods, cathode and anode, right, and connected with put a small bulb over here, okay, complete the circuit, right? This bulb will glow. It means it is conducting electricity. Okay, so it conducts electricity. This bulb will glow. If in case you put NaOH, or if in case you put glucose in the solution, this bulb will not glow. So this is what we mean, what do we mean about electricity, conduction of electricity. The water is become a good conductor of electricity if you put acid solution in it, right? Then release hydrogen ions in aqueous solution. Just now we did. Okay, aqueous solution means, aqueous means when you mix something with water, the solution you get is aqueous solution, right? So it has released the bond between the hydrogen and chlorine broke and we get hydrogen ion. Clear, students? Right. Okay. Then types of acids. Acids are divided into two types on the basis of their occurrence: natural acids and mineral acids, right? HCl is a mineral acid, H2SO4 is a mineral acid, HNO3 is a mineral acids, right? Natural acids, you found natural acids in fruits, right? In fruits, in vegetables, right? And in ant sting. So these are the natural acids. Let's have a look of acids. And these are the common name of acid. You must remember the common name of acid. Acetic acid is common name is vinegar, right? Ascorbic acid, you found ascorbic acid in guava and amla. Okay, citric acid, lemon, orange and other citrus fruit you will find. Then lactic acid, the name suggests lactic. Lact is nothing but milk. So lactic acid you will find in curds, right? Sour milk is nothing but curd. Methanoic acid is also known as formic acid, right? You will find this in ant sting and nettle sting, right? Oxalic acid you will find in tomatoes, and tartaric acid. See, T for tartaric acid and T for tamarind, right? Tamarind is nothing but imli, right? So T for tartaric acid and T for tamarind. So this is how you can learn. And tomato, because you have already done with T, so just remember oxalic acid and omato. This is how you can, you can have little bit of tricks to learn the things. Okay, now coming to mineral acids, acids that are prepared from minerals, okay, known as mineral acids. Example, inorganic acids, man-made acids or synthetic acids, right? We have discussed these mineral acids: HCl, H2SO4, HNO3, carbonic acid, H2CO3, and phosphoric acid, H3PO4. You have to learn the uh, component of these acids, right? You should know the chemical formula of these acids. Okay, every time you won't get HCl or sulfuric acid written over here, right? So you must know the compound or the chemical formula of the acids. How do acids and base react with metal? Now comes the reaction of acids and bases with metals, right? We will first discuss with acids and then we will discuss with bases, base reaction with metal. That we will be going to do in our next session. Okay, so I have taken first reaction, chemical properties of acids. This is very important. Okay, when acids reacts with metal, see, when acids react with metal plus acids gives you salt, right? And hydrogen gas is liberated. Okay, hydrogen gas is evolved. Very, very important thing. This is the basic thing which you have to know, right? Later you can put different metals and different acids in place of acids, and salt and hydrogen gas will be evolved, but this is the basic thing which you should know. So when metal react with acid, salt is formed and hydrogen gas is evolved. Okay, now here's a formula. Zinc, fine, zinc is taken and hydrochloric acid is taken. Okay, zinc is taken in a granulated form, and when we add hydrochloric acid with zinc chloride is a salt. Now children, what do you mean by salt? In salt, if you divide this compound into two halves, you will see one is metal and the other one is what is other one? Radical. Okay, this is not the first time I'm telling you, explaining you. So other one is radical, okay, and the first one is metal. Clear? So metal and radical combines to form what? Salt. And which gas is evolved? Hydrogen gas is evolved. Okay, here you can see here I have taken another metal, right? Sodium plus H2SO4, sulfuric acid. Sodium is a highly active, highly reactive metal, right? We have seen in metal series, right? So potassium was on the top, Kashi, Nath, so Nath next, right? If you remember, I have given you a mnemonic of the reactivity series. I want you to repeat that mnemonic, write it somewhere in your copy, and okay, go through twice or thrice, not every day but once in a week. Okay, so sodium, fine, will replace hydrogen. You will get sodium sulfate, right? And hydrogen gas is evolved, right? So these are the two equations we have taken here, right? See, zinc sulfate, don't consider this sulfate, okay? It's only zinc, okay? It should be solid here, so don't consider this. Right, now there is another activity. All the activities which are given in your book, all activities are important, because application based question will definitely going to ask from these activities. So don't avoid activities. In fact, activities are very, very important. Okay, now Here the reaction of zinc granule will dilute sulfuric acid, right? The reaction which we did in our last slide, this is the continuation of the same reaction with illustration, right? So what you have to take, a test tube, okay? Then you have to, in the test tube, you have to put zinc granules. It should be very fine granules. Now the question can be asked, why do we need to have fine granules of zinc, right? Because when you change into powder, or when you change into granules, its surface area gets increased. When the surface area gets increased, the reaction is become fast. It will be a fast reaction, right? Right. So you have to take few pieces of zinc granules and add 5 ml of H2SO4 hydrochloric sulfuric acid. You can take hydrochloric acid also, or sulfuric acid, right? Shake it and pass the gas produced into a soap solution. Yeah, we are not taking here a plain water solution. We can take, but here we have not taken plain water. Here there is a soap solution. Okay, bubbles are formed in the soap solution, right? Okay, when you pass this hydrogen, this is a delivery tube. Through this delivery tube, the hydrogen gas will be passed into a beaker where we have taken soap solution. When this gas, definitely when gas comes out from the solution, it will form bubbles, isn't it? So it is forming bubbles, right? This bubbles will, okay, go up. It will move up. Why it is moving up? Because we all know that hydrogen gas is a very light gas, right? That is why we use in hydrogen balloons and even in parachute. Okay, fine. So hydrogen gas is used, hydrogen gas is forming bubbles. These bubbles are filled with hydrogen gas, right? Because of the soap, we are getting these bubbles, right? And when you bring a burning splinter near the bubble will burst, okay? And then a pop-up sound will come. So pop-up sound, this is very important. Burning of hydrogen gas with a pop-up sound. This is very, very important. How? Because this is this shows, the pop-up sound shows that the gas is nothing but hydrogen gas, right? Fine. So this indicate that the gas is a hydrogen gas. The soap bubbles contain hydrogen gas, right? So this you have to write the reaction: zinc plus H2SO4 ZnSO4 hydrogen gas. And when you are writing hydrogen gas, you have to put this arrow sign. Children, this is very, very important to put this arrow sign, right? You might lose marks just in case you don't put this arrow sign, because this is a gas which is evolving, and the downward arrow shows the precipitate. Okay, then test for hydrogen gas we have done. The evolved gas is a hydrogen gas. It can be tested by bringing the burning candle near the bubble soap. Hydrogen gas burn with a pop sound. Okay, pop sound. Okay, now we have done, so we will have a look of the questions which can come on the topics that we have discussed, right children? And this question I have taken from your book, in text question, right? So question number 1, this is taken from the page number 18. Okay, you have been provided with 3 test tubes. One of them consists distilled water, the other contains acid solution and the basic solution, right, respectively. If you are given only red litmus paper, see here they have made a change. You have given only red litmus paper. How will you identify the content of each test tube, right? So you can see we have already done, right? When you put red litmus paper in water, nothing will change. When you put red litmus paper in acid solution, nothing will change. When you put red litmus paper in basic solution or test tube which has base, right? So you put in that solution, that red litmus paper will turn into blue litmus paper, and hence you can identify that the solution in that test tube is basic. Okay, and in the rest of the test tube there won't be any change, right? Fine, don't try to taste the solution, please don't do that. Okay, now in the next question taken from page number 22, Why should curd and sour substances not to be kept in brass and copper vessels? See, brass and copper vessels, they are reactive metals, right? And when you put these curd and sour substances, that means it has acid in it, right? These acids will react with metal and then they can form any kind of poisonous metal compound. So the possibility of forming poisonous metal compound is more, okay? So which can cause food poisoning and affect your health adversely. Nowadays, it is advised even not to cook any sour or any acidic thing in a aluminium vessel, right? Because we use aluminium vessels, right? So it is not advisable. Clear? Here, the next question: which gas is usually liberated with when an acids react with metal? Just now we did. Okay, hydrogen gas is liberated, right? And illustrate this with an example. So illustration, the answer, sorry, in activity 2 we did uh, this illustration. That means a diagram was drawn. Same diagram you have to draw, okay, and then you have to write the whole procedure, and then what is the observation, what is the what did you observe at the end of the uh, this activity, right? So all you have to write. So this question can come for 5 marks. Illustration is there, definitely it can come for 5 marks, and which is very important. Okay, you have to write equation, which is very important. You have to write procedure, you have to write observation, clear, and drawing of picture, right? Because illustrate is given, so you need to draw the whole setup of apparatus, right? So hydrogen gas is liberated when acid react with metal. We know that. Illustration: set up the apparatus as shown in the activity. Sorry, there is a mistake over here. Activity. You have to take some zinc granule and you need to write all procedures that we have already done. Children, here I am going to stop about acid, and the rest of the reactions with acids and basic we are going to take, I'm going to take in my next session. Tomorrow there is a session of biology, so I'm taking biology in 2 consecutive days, right? Tuesday and Wednesday I'll take biology, Thursday and Friday I'll take physics. So we will almost complete 1 chapter of biology and hopefully 1 chapter of physics, right? So thank you children. Practice today's topic: